These are your notes for Unit 6, Day 3 of Algebra 1. If you would like to see the warm-up, the review question, or any homework questions we covered in class today, just look at the finished notes. So today we are going to talk about how to multiply polynomials. So we'll start by using the distributive property, which we've done a couple times in the past. We'll talk about how to multiply two binomials and two polynomials. I'll show you two different methods for doing that. One is just kind of like the distributive property, and one is using a multiplication box or a factor box. We will be able to square a binomial, so take a binomial times itself, and we will be able to multiply and identify some special products. So multiplying monomials. So this is a review of a couple classes ago. So if you want to multiply two monomials together, this is like the product rule for exponents. So remember, if two terms have the same variable and you're multiplying them, you can add the exponents. So if they have the same base, you can add the exponents. If they have coefficients, you get to just multiply the coefficients. So -7 times -3 is positive 21. And then x to the 5th times x to the 3rd. Remember, if you expanded it out, you would have 5x's and 3x's being all multiplied. So you would have x to the 8th, or you can add the exponents. 5x to the 10th times 10x to the 9th times -5x to the 6th. Again, we can multiply the coefficients. So 5 times 10 is 50. 50 times -5 would be -250. And then x to the 10th, x to the 9th, x to the 6th. We can add those exponents, and we get x to the 25th. So we get -250 x to the 25th. On the next one, 7y to the 3rd times 5x to the 10th y to the 3rd. So coefficients, 7 times 5 is 35. And then y to the 3rd and y to the 3rd becomes y to the 6th. And then you just have the x to the 10th. So it'll be x to the 10th, y to the 6th. We typically write them in alphabetical order, so we'll put the x's before the y's. Next one, 4 times 3 is 12. And then x to the 2nd times x to the 2nd is x to the 4th. Y squared times y to the 4th is y to the 6th, and then we just have a z squared. So it'll be 12x to the 4th, y to the 6th, z squared. And that's just taking a monomial, so one term times one term. We can also use the distributive property to multiply a monomial times a polynomial, so a binomial, a trinomial, etc. So you just distribute it in, and it's like taking a monomial times a monomial one at a time. So 8n times 7n, 8 times 7 is 56, and n times n would be n squared. 8n times 3 is 24n. So that's just going to become 56n to the 2nd plus 24n. 2b to the 3rd times the quantity b minus 3. So 2b to the 3rd times b would be 2b to the 4th. And 2b to the 3rd times -3 would be -6b to the 3rd. 6x times the quantity 7x squared minus x minus 5. Distribute in the 6x. 6x times 7x squared would be 42x to the 3rd. 6x times -x would be -6x squared. And 6x times 5 would be -30x. Distribute in the 8x to the 5th. 8x to the 5th times 6x to the 2nd would be 48x to the 7th. 8x to the 5th times -8x would be -64x to the 6th. And 8x to the 5th times -1 would be -8x to the 5th. So that is using the distributive property to take a monomial times a polynomial. So go ahead and pause the video and see if you can do these three using the distributive property. All right, so if you distribute in 7k, you would get 14k to the 2nd minus 49k. On the next one, if you distribute in 2n, you would get 6n to the 3rd plus 10n squared minus 12n. If you distribute in the 3k squared, you would get 3k to the 4th plus 21k to the 3rd minus 9k squared. All right, so multiplying binomials. So I told you I'm going to show you two different ways to do each of these problems. So the first way we're going to do it is we're going to do it with the multiplication box. So we're going to make a box, And then I'm taking x plus 1 times x plus 1. So I'm going to take x plus 1. That'll be my first thing that I'll write. So x plus 1. And then down the side, I also have x plus 1 because I'm doing x plus 1 times x plus 1. And now you just multiply like you would in a multiplication table. So I'm going to take x times x to get my first box. X times x is x squared. To get this second box, I'm going to take x times 1, and x times 1 is 1x. And then same thing here, x times 1 is 1x. And then 1 times 1 is 1. So we get x squared plus 1x plus 1x plus 1. So if I wrote this out, I would get x squared plus 1x plus 1x plus 1. If I combine like terms, I get x squared plus 2x plus 1. All right, or that's option 1. Option 2 is you can think about this as distributing twice. So you take every term in that first parentheses, the x plus 1, and you distribute to the second parentheses. So I'll take x times x and x times 1. X times x is x squared. X times 1 is 1x. And then you do the same thing with the second term in the first parentheses. So I'll distribute that 1 to both terms in the second parentheses. So 1 times x is 1x. And 1 times 1 is 1. And if you notice, these terms that I got in the box and these terms that I got when I distributed are the exact same. So when I simplify, I would still get x squared plus 2x plus 1. Each method has its benefits. The method on top where you just distribute is a little bit faster. It requires less writing because all the writing is already done for you. The one thing is when these problems become longer, when you take like a trinomial times a binomial or you just have more terms involved, you're more likely to miss a term when you're multiplying. So you're more likely to miss one of the terms that we multiplied out. With the box method, you know exactly how many terms you need because it's how many boxes there's going to be. So both methods are okay. Both methods work. It's really up to you what you like better. The box method, though, I've tended to notice that students are more accurate with their final answer if they use the box method. All right, so x plus 2 times x plus 3. We'll start with the box method. So let's put our box. And then we have x plus 2, and we have x plus 3. And then we'll multiply. X times x is x squared. X times 2 is 2x. X times 3 is 3x. And 3 times 2 is 6. And then if I combine the like terms, the 2x and the 3x are like terms. So I get x squared plus 5x plus 6 using the box method. Or using the distributive method, take the first term in the first parentheses and distribute it, and you would get x squared plus 3x. And then take the second term and distribute it, so plus 2x plus 6. And if you combine the like terms in the middle, you get x squared plus 5x plus 6. And there you go. Next one, x minus 6 times x plus 2. Let's do the box method first. So x minus 6 and x plus 2. X times x is x squared. X times negative 6 is negative 6x. X times 2 is 2x. 2 times negative 6 is negative 12. And if you combine like terms, negative 6x plus 2x is negative 4x, and then minus 12. So we get x squared minus 4x minus 12. Or using the distributive method, we get x times x is x squared. X times 2 is 2x. Distribute the negative 6, and we get negative 6x minus 12. So we get x squared minus 4x minus 12 using the distributive method. I apologize, my dog is playing with a toy right now. All right, next one. Using the box method, we have 2x minus 1, and then x minus 3. So 2x times x is 2x squared. X times negative 1 is negative 1x. 2x times negative 3 is negative 6x. And negative 3 times negative 1 is positive 3. And if we combine the like terms of negative 1x and negative 6x, we get negative 7x. So we get 2x squared minus 7x plus 3 as our final answer with the box method. Or using the distributive method, 2x times 1x is 2x squared. 2x times negative 3 is negative 6x. Negative 1 times x is negative 1x. And negative 1 times negative 3 is positive 3. Combining like terms, 2x squared minus 7x plus 3. All right, So you guys go ahead and use whatever method you like best and multiply these 3 binomial times a binomial. All right, so on number 1, y plus 6 times y plus 5, y plus 6, y plus 5, y times y is y squared, y times 6 is 6y, y times 5 is 5y, 6 times 5 is 30. So we get y squared plus 11y plus 30. Or using the distributive method, y times y is y squared, y times 5 is 5y, 6 times y is 6y, 6 times 5 is 30, so you get y squared plus 11y plus 30. On our next one, x plus 5 times 3x minus 1. So x plus 5, 3x minus 1, and we get 3x squared. X times 3x is 3x squared. 3x times 5 is 15x. X times negative 1 is negative x. 5 times negative 1 is negative 5. Combine like terms, and you get 3x squared plus 14x minus 5 when you multiply those out. Or using the distributive method, x times 3x is 3x squared. X times negative 1 is negative x. 5 times 3x is 15x, and 5 times negative 1 is negative 5. So 3x squared plus 14x minus 5. Last one, we've got 3x minus y times x plus 2y. So we get 3x squared minus xy plus 6xy minus 2y squared. So combining like terms, you would get 3x squared plus 5xy minus 2y squared. You would get the same thing if you use the distribute method. All right, so squaring binomials. Remember when you square something, like if you have x squared, it means x times x, or 3 squared means 3 times 3. So when you square something, you're multiplying it by itself. So if you had x plus 3 squared, that means that you're taking x plus 3 and you're multiplying it by itself, x plus 3. So we're taking x plus 3 times x plus 3. This does not work the same way as the power rule. So this is not the power rule where we get to distribute that exponent in. That is no. That makes us sad. We do not distribute the exponent in to binomials. It doesn't work the same way. So if I did x plus 3 times x plus 3, so x plus 3 times x plus 3, I would get x squared plus 3x plus 9. So combining like terms, I would get x squared plus 6x plus 9. So again, when you square a binomial, you're multiplying that binomial by itself. So times itself. So this is going to be a minus 4. That whole thing squared would be a minus 4 times a minus 4. And so if we used our box method, a minus 4, we would get a squared minus 4a minus 4a plus 16. Combining like terms, we would get a squared minus 8a plus 16. Next one. 4x minus 3y, that whole thing squared, would be 4x minus 3y times 4x minus 3y. And so if I used the box method, 4x minus 3y, 4x minus 3y, and I would get 16x squared minus 12xy minus 12xy plus 9y squared. So if you've noticed, when you're squaring a binomial times a binomial, these two terms are going to be identical. 3x, negative 4a, negative 12xy, negative 12xy. So those two middle terms are going to be identical. So combining like terms on this last one, I would get 16x squared minus 24xy plus 9y squared. And that's how you would square a binomial. All right, go ahead and pause the video and try these two, y minus 2 squared and 3p plus 5q squared. All right, y minus 2 squared means y minus 2 times y minus 2. And so if I were to multiply these out, I would get y squared minus 2y plus 4. And so y squared minus 4y plus 4 when I combine like terms. And 3p plus 5q squared would be 3p plus 5q times 3p plus 5q. And if I multiplied these out using the box method, 3p plus 5q, 3p plus 5q, I would get 9p squared plus 15pq plus 15pq plus 25q squared. And so I get 9p squared plus 30pq plus 25q squared. So that, again, is squaring a binomial. Multiplying polynomials. So again, I told you that the box method may take a little bit more time, but you're less likely to miss pieces if you use it, especially when you're multiplying bigger guys. So 6a minus 6 times the quantity negative 2a squared minus 4a minus 8. So I'll show you how to use it with both the box method and using the distributive method. So we have 6a minus 6. And then we have 3 terms, so negative 2a squared minus 4a and minus 8. So notice the box is going to tell us exactly how many terms we need when we're done. I'm going to make this look more like an a instead of a 9. And so now a negative 2a squared times 6a is negative 12a cubed. Negative 2a squared times negative 6 is positive 12a squared. 6a times negative 4a is negative 24a. Negative 4a times negative 6 is positive, oops, this is 24a squared, and this would be 24a. 6a times negative 8 would be negative 48a, and negative 8 times negative 6 is positive 48. So now if I combine like terms, I get negative 12a cubed, and notice where the like terms fall. They're going to be in the diagonals. So negative 24a squared plus 12a squared is going to be negative 12a squared. And then negative 48a and positive 24a is going to be negative 24a, and then plus 48. Oops. And so that will be my final answer of taking that binomial times the trinomial. Or you can use the distributive method. So I would take 6a and multiply it by all 3 terms this time. And I would get negative 12a cubed minus 24a squared minus 48a. And then I would take the negative 6 and distribute it. And I would get positive 12a squared plus 24a and plus 48. And then if you combine like terms, you would get negative 12a squared, negative 12a cubed, and then minus 12a squared, and then negative 24a, and then plus 48. And notice it's the exact same answer that I got down below. So whatever method you like better, again, the distribute method or the box method, go ahead and use for your homework. All right, on the next one, we have a trinomial times a trinomial. So again, let's use the box method. I'm going to have to make a bigger box because it's a trinomial times a trinomial. So r squared plus 6r plus 5. So I got 3 columns. And then I've got 5r squared plus r and minus 5. I've got 3 rows. And now I'm going to multiply everybody. 5r squared times r squared is 5r to the 4th. R squared times r is r cubed. R squared times negative 5 is negative 5r squared. 5r squared times 6r is 30r to the 3rd. R times 6r is positive 6r squared. Negative 5 times 6r is negative 30r. 5r squared times 5 is 25r squared. R times 5 is 5r, and negative 5 times 5 is negative 25. And so if I simplify this, I've got 5r to the 4th, and then, again, my like terms happen to be in diagonals again, so 1r to the 3rd plus 30r to the 3rd would be 31r to the 3rd. And then I've got 25r squared, 6r squared, and negative 5r squared, which is going to be 26r squared. And then I've got 5r and negative 30r, so negative 25r, and then minus 25. Or if you use the distributive method, you'd have to distribute 3 times. So r squared would go to all 3 terms. Negative 6r would go to all 3 terms. And then the 5 would go to all 3 terms. And you'd end up with the exact same terms you got in the box. And then when you combine like terms, you'd end up with our answer. All right, so go ahead and pause the video and try the next 2 using whatever method you like best. All right, I'm going to use the box method. So we have x squared plus 2xy plus y squared, and we have x minus 2y. So x times x squared is x cubed. X times 2xy is plus 2x squared y. X times y squared is xy squared. X squared times negative 2y is negative 2x squared y. Again, I just put them in alphabetical order, so I'm putting the x's first. 2xy times negative 2y is negative 4xy squared, and negative 2y times y squared is negative 2y cubed. Combining like terms, we have x to the third, and then 2x squared y minus 2x squared y, they cancel each other, so there'll be no x squared y terms. Negative 4xy squared and positive 1xy squared would be negative 3xy squared, and then minus 2y cubed. All right, on my next one, I have a trinomial times a trinomial, so I'll need a bigger box. And we have 3k, oops, not 3k squared, 5k squared plus 3k plus 3, and then times 3k squared plus 3k plus 6. And if I multiply this out, I would get 15k to the fourth plus 15k to the third plus 30k squared plus 9k to the third plus 9k squared plus 18k plus 9k squared plus 9k plus 18. And if I combine like terms, I get 15k to the fourth plus 24k to the third plus 48k squared plus 27k plus 18. So if all of my math was correct, that should be the answer. And that's how you can multiply polynomials by polynomials. So some special products that are going to pop up more and more as we deal with more binomials and trinomials, and we're going to do something called factoring eventually, are as follows. So what happens if I take x plus 8 times x minus 8? What's going to end up happening? So notice I have an x and an x, but then I have a positive 8 and a negative 8. So if I go to multiply these, what's special about it? Well, let's find out. So we have x plus 8 times x minus 8. So we have x squared, we have plus 8x, we have minus 8x, and we have minus 64. What happens to those two terms that are the like terms? They're going to cancel. I wonder if that happens every time you have something like x plus 8 and x minus 8. So my final answer will be x squared minus 64. And notice x times x is x squared, and 8 times negative 8 is negative 64. Well, on the next one, we have 4x plus 8 times 4x minus 8. So again, we have a 4x and a 4x, and then we have a positive 8 and a negative 8. So let's see if the same thing happens. Well, those middle terms cancel out. So let's try this. So 4x plus 8 and 4x minus 8. So we have 16x squared plus 32x minus 32x and minus 64. It happened again. We have negative 32x and positive 32x. They're going to cancel with each other. And what I'm going to be left with is 16x squared minus 64. So I'm only left with 2 terms. Well, the next one worked the same way. V plus 4 squared. Well, remember we've done this before. V plus 4 squared means to take V plus 4 times V plus 4. So if I multiply this out, I get V plus 4 and V plus 4. So I get V squared plus 4V plus 4V and plus 16. Well, we talked about this. This time they don't cancel, but those two middle terms are the same. We have 4V and 4V. So we're going to end up with V squared plus 8V plus 16. So it looks like the only time those middle ones will cancel is when they have opposite signs, like plus 8 and minus 8. All right, let's look at the next one. 1 minus 6n squared. Remember, it means 1 minus 6n times 1 minus 6n. And so if I make my box, 1 minus 6n, 1 minus 6n, I get 1 minus 6n minus 6n, then plus 36n squared. Let's put this in descending order. So I would have 36n squared. Negative 6n and negative 6n are negative 12n, and then plus 1. And again, the middle terms didn't cancel. They were the same, and they didn't cancel. All right. Go ahead and pause the video and try the next 3. All right, so x minus 4, cubed. We haven't done one like this. So this would be x minus 4 times x minus 4 times x minus 4. So we don't do a 3D box. What we're going to do is we're actually just going to multiply the first two x minus 4s first, and then we'll multiply by the last x minus 4 when we're done. So let's do x minus 4 times x minus 4. So x minus 4 times x minus 4, we get x squared minus 4x plus 16. So combining like terms, I get x squared minus 8x plus 16. So that's what those first two parentheses become, but I still have an x minus 4 that I haven't multiplied. So now I have to take x squared minus 8x plus 16 times x minus 4. So let's make our box. So x squared minus 8x plus 16 times x minus 4. And we get x cubed minus 8x squared plus 16x minus 4x squared plus 32x minus 64. So combining like terms, we get x to the third minus 12x squared plus 48x minus 64. So if you are multiplying 3 binomials or 3 polynomials, you can multiply the first two first, and then whatever you get, you can multiply that by the last one. All right, let's look at the next one. 2x minus 4 times, 2x minus 1/4 times 2x plus 1/4. Well, it looks like you have the exact same thing, but one's plus and one's minus. So let's see if those two middle ones will cancel when we do this one as well. So 2x minus 1/4, 2x plus 1/4. So 2x times 2x is 4x squared. 2x times negative 1/4 would be negative 2/4 x. 2x times positive 1/4 would be positive 2/4 x. And 1/4 times negative 1/4 is negative 1/16. Well, notice the two middle terms are the same but opposites, so they're going to cancel each other. So I'm just left with 4x squared minus 1/16. All right, on the next one, I have x minus 4 plus y squared. Well, those parentheses on the inside really aren't doing anything. It's just doing anything. So it's x minus 4 plus y, and I'm squaring that. So times x minus 4 plus y. So I'm going to distribute on this one because we haven't distributed in a while. So I'm going to take x times x times negative 4, and x times y. So I get x squared minus 4x plus xy. And then I'm going to distribute the negative 4. So negative 4 times x, negative 4 times negative 4, and negative 4 times y. So let's make this smaller. Okay. And so we get negative 4x plus 16 minus 4y. And then we're going to do our last one. So we're going to distribute the y to x and negative 4 and y. And we would get plus xy minus 4y and plus y squared. And if you combine all your like terms, you get x squared, negative 4x and negative 4x is negative 8x. xy and xy make 2xy. Negative 4y and negative 4y make negative 8y. And then we have a 16 and a y squared. So plus 16, well, we'll do plus y squared and plus 16. I apologize for my dog. So we should have x squared minus 8x plus 2xy minus 8y plus y squared and plus 16. All right.